Hello everyone. In this video I would like to discuss and summarize the properties of rectangles, and then I want to use one of these properties to do an example. So first thing, rectangles, these are parallelograms. So all of the properties of a parallelogram also apply to rectangles. So the main thing here is that the opposite sides are parallel. That's the definition of a parallelogram. So we know the opposite sides are parallel. So let's see, we got AB is parallel to CD and AD parallel to BC. Also, because it's a parallelogram, we have other properties that we got from theorems. Things like the opposite sides are congruent. So the top and bottom, they're congruent. And the left and the right side, these are congruent. So AB is congruent to CD, and AD is congruent to BC. We also know that the diagonals bisect each other. So if I draw these in, we got diagonal AC, and then the other diagonal BD. And then let's label this intersection as M. So the diagonals bisect each other, so AM is congruent to CM, and then BM is congruent to DM. Another property of parallelograms is the opposite angles are congruent to each other, but the definition of a rectangle is it's a parallelogram that has 4 right angles. So all of these angles, they're all 90 degrees, they're all congruent. So I'm going to say that all 4 are congruent to each other. And let's just say that all are right angles. So that's the definition of a rectangle. And then from the definition of a rectangle, and then using some of the properties of parallelograms, there's one additional special property that is specific for rectangles, and that is the rectangle diagonals theorem, which states that the diagonals of a rectangle are congruent to each other. So that means diagonal AC is congruent to diagonal BD. So the entire length AC and BD are the same. Up here we also said that the diagonals bisect each other. So when we split this, that means that all 4 of these segments are actually the same. And this last property of rectangles, this is the one that I actually want to use for my example. So let's take a look at that. So it says in rectangle QRST, I'm given some information about QS, it's 5x minus 31, and RT, 2x plus 11. I want to find the length of the diagonals. So to do that, I need to find x, and after we find x, we can plug it back in to find the length. So because this is a rectangle, that last property, I know that QS has to be the same as RT. The diagonals have to be equal to each other. So that allows me to set up this equation. So substituting in what we know, 5x minus 31, that has to be equal to 2x plus 11. And now solving this equation, just use our algebra. So subtracting 2x, adding 31. So we get 3x is equal to 42. And then dividing both sides by 3, we get x is 14. And now that I know the value of x, we can plug that back in. And since they're the same, it doesn't matter which one we use. So I'm just going to plug this back into the second one. So 2 times 14 plus 11. This is 28 plus 11, which is 39. So that means QS and RT are both 39.